Look at this now. Look at the board. Look at the board. You can see this is geometric series. Is that correct?
Yes.
With r equal to 2 over 3. Abi now? Do you understand what I just said? This is a geometric series with a equal to 1 and r equal to 2 over 3. Since modulus of r is less than 1, it is convergent. Do you understand that? Then move on. The next one is what? This is going to be
A P series.
yeah, you can write this as root n over
Yes.
root n squared.
Yes, yes, sir.
That will be 1 over root n.
I think this one.
Do you understand that?
Yes.
That will be 1 over n raised to power 1 over 2. So this P series with P equal to 1 over 2. Is this convergent or divergent?
Divergent.
So that's your
this
answer.
has been-
Move on.
Next,
Did you get that? Alright. So the next one, if you wanted to consider the next one, what would this be?
convergent.
Convergent, P series, with n equal to 2. What
So
of
we can
this?
use ratio.
This is a geometric series
Eh.
with r equal to 1 over 2. Yeah, very smart one.
Very
So,
smart move.
yes,
No reason
smart move. This is a geometric series with r equal to 1 over 2. You know you can write this as 1 over 2 all raised to power n. You get. Right. What of this?
You can use
You can use ratio test. Yes. to check if
So
it's
can we not use
convergent.
ratio test for this one? For the
For D?
You can use
Yes, now you can use ratio test, but that's waste of time.
yeah.
anyways. Just notice it is a
That's
geometric
good.
series.
That's good. Let's go.
Get your answer. Alright, I said we should solve some questions on limits. I'm trying to locate one.
I will not see.
Ah,
This one. Limits. I'm not interested.
Limits and sequences.
Sir, please, the conditions for continuity and differentiability. This is scatter in my head.
okay, continuity. Continuity, listen now, listen. The function f of x, this continuity for a single variable function. We've considered that of a two variable function under partial derivative. Okay? A function f of x is said to be continuous at a certain point x naught if number one, the limit of f of x as x approaches x naught exists. That means it's going to give you some real number. Number two, f of x naught exists or is defined. And number three, if both of them are equal, the limit of f of x as x approaches x naught is equal to f of x naught. Is that clear? That's the limit, that's the condition for convergence. And you can also summarize everything as this. So if this one exists and this one exists, then, and they are equal, then the function is continuous at that point x naught. Continuity in an interval means that the function is continuous at every point in the interval. Can you remember that? Continuity of the function in an interval. Then we talk about differentiability. I said differentiability means that you can get the derivative of that function. Now, where I told you that this is derivative of, when you take the differentiation from the first principle, you usually say that the y, the x, is equal to the limit of this as delta x approaches 0. Abi? So it is when this limit exists, I would say that the function is differentiable. But here we are not using delta y. Instead of delta y, we're going to use this. We say that f of x naught plus h, is that clear? Minus f of x naught all over delta x. Delta x is what we are representing as h here, as h approaches 0. So if this limit exists, okay, we say that the function is differentiable at x equal to x naught. Is that clear? So this is the limit of this at x equal to x naught. So that's what we found there. So if this limit exists, the function is differentiable at x equal to x naught. And that value will give us the derivative at x equal to x naught. So we find the derivative as we do for other cases. So I'll give this a try. You want to look at this now. You have been asked what this sequence converges to 4 times 10 raised to power n minus 3 times 10 raised to power 2n. This is a sequence. To what value does this converge? Divided by 3 times 10 raised to power n minus 1 plus 2 times 10 raised to power 2n minus 1. Okay. N equal to 1 to infinity. To what value does this converge? How do you get the value to which it converges? You get the limits as n approaches infinity. This is a sequence, Abi. So to what value does this sequence converge? So give it a try.
Which one?
This sequence. So what value does it converge? That's limit. Now you want to get the limit as n approaches infinity. So what is the limit of that as n approaches infinity? Everybody give it a try.
That's n approaches infinity.
So we are also given this function. It is defined such that it is 0 when x is less than or equal to 0. This is a very vital question that you usually come across on continuity. So you are being asked this question: what can you say about this function above? A, it is continuous at x equal to 0 and discontinuous. Discontinuous at x equal to 1 over 2. B, it is continuous at x equal to 0 and discontinuous I'm repeating the same question. Continuous at x equal to 0 only, and C, discontinuous at both x equal to 0 and x equal to 1 over 2. D, continuous at x equal to 1 over 2 only, and E, continuous at both x equal to 0 and x equal to 1 over 2. So have you solved the first one? What did you get? Have you solved the first one? What did you get? What's the time, please?
Minus 3 over 2.
Okay.
Minus 15.
No, yeah, this is sequence, so not series. You want to get convergence of a sequence, just take the limits as n approaches infinity.
10, 15, minus 15.
Minus 15. What did you get?
I'm just.
You're just guessing. Don't guess.
No, I'm not
now,
guessing.
work it out.
What I worked.
Is
Yeah,
what?
I'm not sure. Minus 15.
I want to be sure. I prefer you don't work at all. I'm very serious. I prefer that you don't do anything at all. That you do it and you are not sure of yourself. That's more ridiculous. Yeah. So be sure of yourself. Do it again.
Okay. Let's do it again. Voice.
I'm going to say that of that 4 dots 10 divided by
Divide now.
divided by 3.
Divide everything by 10 raised power. Divide everything by 10 raised power 2 minus 1. Divide everything by 10 raised power 2.
Is it because I mean I don't want to divide now. I've been
I'm factorizing out. I'm not dividing.
let me try dividing. No, actually dividing should make sense.
So minus 1. Minus 10. I'm sure.
Yeah, sure. What did you get?
Minus 15.
Minus 15. Okay. Minus 15. Okay, minus 15 is in the option. So we solve this and round off here. So please go and practice more questions. Practice the questions you have in your notes. Listen, please, listen. So far I've been giving you questions on each topic. Those questions are extracted from your lecture notes. Okay. So please go and practice them again. And then on limit also, go through your lecture notes, practice the questions there. If there's any issue, post it on the group. So I will respond before the end of today. I will respond before the end of today. Okay. So ensure that you do that. So let's quickly solve these two and go.
Plus 2 times n squared.
This one is fun.
Now say let's take this power n because we have and 24 minus 3.
So look at something, please. Look at something. We want to get the limit of this as n approaches infinity. And I told you the idea with limit at infinity is that you can divide through by the highest power altogether in the denominator. Does it make sense? So what's the highest power in the denominator here? 2n minus 1, Abby? So I can divide all through by 10 raised to the power 2n minus 1. Does that make sense?
Yes, sir.
Okay, so that is, I'm going to have this to be the limit of 4 times 10 raised to the power n minus 2n minus 1. Does that make sense? Do you understand what I'm doing?
So you said divide through.
Yes,
the
10 divided by 10 raised to the power 2n minus 1. Abby?
In the denominator,
So
yes.
this one will be 10 raised to the power n divided by 10 raised to the power 2n minus 1. That is 10 raised to the power n minus 2n minus 1. That's what I've written here.
Yes, I know.
Yeah.
That's what I'm asking, but don't worry. Continue.
Okay, so the next one will now be what? Minus 3 multiplied by 10 raised to the power 2n minus 2n minus 1. Does that make sense? Do you understand this? So this will be what? Divided by 3 times 10 raised to the power n minus 1 minus 2n minus 1. Then what? Next one will go up plus 2. Is that clear? Then you have this to be equal to the limit as n approaches infinity of, what would this be now? 4 times n minus 2n. That's minus n, Abby. That will be 10 raised to the power minus n plus 1. Does that make sense? Then you're going to have minus 3 multiplied by 10. 2n minus 2n, that's gone, Abby. Then minus 1, that's going to be 1. Minus of minus 1. Alright, then you have this to be 3 multiplied by 10 raised to the power. This will be n minus 2n. What is that? Minus n. Abby? Then minus 1 plus 1. That's 0, Abby. So that one is gone. Then plus 2. Is that clear? Alright. Then now, as n approaches infinity, I'm going to have 10 raised to the power minus infinity. That is 0. Is that clear? 10 raised to the power minus infinity, 0. So we can just say this is going to be equal to 0 minus 30 all over 0 plus 2. That is minus 15. Life can be as easy as that. Do you get it? Do you get it? Alright. So let's answer this second one. Right, if you need to write that.
The denominator.
Yeah, I do. I'll just use we are spread by
Oh, n. N is. You know, n is greater.
So,
Wait, or did I do so this one now?
How far now? You get it now?
Okay, that was it.
I was at the top. This is the power. Those that you started in school.
Okay.
So that's this is 1. This is 0.
So what is that?
This one is 2.
It feels like X is going to be. What's yours? This answer, you got what? I swear it doesn't.
Another question.
Okay, can I move on? Can I clean this? Can I clean this? Yes.
Actually, if you from positive set 0.
Okay. So look at this now. I told you that if you are asked to comment on the continuity of a piecewise function, you should just examine its behavior at the breaking points. Can you remember that?
Yes, sir.
So what are the breaking points of this piecewise function? 0 and 1 over 2. So you examine its behavior at 0 and 1 over 2. Do you understand that?
Yes.
Alright, so at 0, let's consider it at x equal to 0. What's the first thing you want to get? The definition of the function. F of 0 is what? F of 0 is what? F of 0 is 0. Abi?
Yes.
This is the definition that applies when x is less than or equal to 0. Do you get that? Yes. Then we will find the limit. And I told you, whenever you need to find the limit, you should find the limit from above, Abi. So you want to get limit of f of x as x approaches 0 from above first. Is that clear? Then we also get from below and see if they are the same. So this is going to give us what? From above. That means something that is greater than 0. Abi?
Yes, sir.
But as close as possible to 0. Is it making sense?
Yes.
You know, you can say that x being greater than 1 over 2, that means it's greater than 0. But it doesn't cover the interval altogether, which we want to cover. We want something that is very close to 0, but not exactly 0. Is that clear? So we cannot take that from 1 over 2. It has to be here, altogether.
Yes.
That number, that definition for x lying between 0 and 1 over 2 is what applies. So this is going to be the limit of 1 over 2 minus x as x approaches 0. Now we don't put the plus any longer because we have used the plus to determine the definition we are using. Is that making sense?
Yes.
Okay, so from here, we are going to substitute 0. This is going to be 1 over 2 minus 0. That's 1 over 2 when you get the limit from above. Then we get the limit from below. Abi? Yes. That will be the limit of f of x as x approaches 0 from below. That's going to be what? The limit of this as x approaches. What's the definition? When you are going from something less than 0 or as close as possible to 0. That's what? 0. So this is going to be equal to the limit of 0, which is 0. So it's obvious that because the limit from above is not equal to the limit from below, the limit does not exist. Do you understand that? Yes. Alright, so we say that since the limit does not exist, that means the function is discontinuous. Abi?
Yes.
So anything that has continuous at x equal to 0, we know it is already wrong. Abi?
Yes.
This option is wrong. This option is wrong. What else?
E is wrong too.
E is wrong. Alright, so our answer is now between this and this. Abi?
Yes, sir.
You get that? So we will check for the other one if it is continuous or not. Does that make sense? Before we can make a choice between C and D. So let's check for the other one. So don't forget the conclusion here. Since the limit of f of x as x approaches 0 from below is not equal to the limit of f of x as x approaches 0 from above, the limit of f of x as x approaches 0 does not exist. So because it does not exist, then one of the rules for the existence or for the continuity of the function is broken altogether.
Yes,
you know, for the function to be continuous, f of 0 must exist altogether. Our limit as x approaches 0 must also exist, and the two must be equal. Do you understand that? Yes. Right. So we have established now that the function is not continuous at x equal to 0. What if I ask you this? Is the function right continuous or left continuous at x equal to 0?
No. Okay.
Eh? Is it right continuous or left continuous? Eh? Left continuous. Why? Because the limit from the left is equal to the definition of the function. Is that clear? It is left continuous, but it is not continuous. For it to be continuous, it has to be continuous to both ends. Together.
Yep.
Alright, so we will find out for x equal to 1 over 2. So at x equal to 1 over 2, what are you going to get? At x equal to 1 over 2, what is f of 1 over 2? F of 1 over 2 is equal to, so when x is 1 over 2, which of them will apply? Which of the definitions apply for x equal to 1 over 2?
1 over 2 minus x.
Yeah, 1 over 2 minus x. So this is 1 over 2 minus x is 1 over 2. That is 0. Is that clear? Yeah. Then we'll find the limit from above. Limit of f of x as x approaches 2 from above. That's going to be what? So we're going to use a definition for, sorry, 1 over 2 no. So what's the definition? When it goes from above, from something greater than 1 over 2. Abi? That's what? 1 over 2. So this is going to be the limit of 1 over 2 as x approaches 1 over 2. That is just 1 over 2. Then we find
1 over 2.
Then we find the limit of f of x as x approaches 1 over 2 from below. You know, the way you are tired is the way I'm also tired. My ex because I've been awake since recording videos. So it's very, very early in the morning. So this is going to be 1 over 2 from below. What definition is that? This, right? 1 over 2 minus x. So that's going to be equal to the limit of 1 over 2 minus x as x approaches 1 over 2. That's going to be 1 over 2 minus 1 over 2, which is 0. So what would you say about that? Limit from above is not equal to limit from below, Abi? That means the function is not continuous, Abi? Because the limit does not exist. But just like at x equal to 0, it is also what? It is left continuous in this case. Abi now? At x equal to 1 over 2. So what's our answer now? C. Continuous at both x equal to 0 and x equal to 1 over 2. Alright, ladies and gentlemen, that's the end of the revision class.
You let me choose. Let me.
Leibniz. Okay, we're not taught Leibniz. No. Yeah, I think I taught you before the strike. But it's not in your material, so that's why I didn't bother again.
No, that's not time now.
Let's go.